So without any further ado, I'd like to introduce our first speaker. John Collomosse is a professor at the University of Surrey, the Center of Vision, Speech and Signal Processing, the CVSSP, with interests in representation learning for visual search and content authenticity. He is director of Decade, which is a multidisciplinary research center exploring the intersection of computer vision, AI, and blockchain technologies. John also serves on the advisory board of the UK Engineering and Science Council, EPSRC, and the UK RI Digital Economy. Over to you, John.
Thank you, Laura. Thank you for the introduction. I'll share my screen. I hope that's coming through okay. Okay, yeah, so again, thank you for the introduction, Laura, and thank you everybody for joining this afternoon for the talk. My mission in the next 15 minutes or so is to give you a snapshot of some of the research going on in CVSSP as it relates to visual search. We're a large computer vision research group based at the University of Surrey. Quite a few of us are working on visual search technologies, and the reason I want to provide a snapshot is to really kind of give a flavour of the possibilities of visual search technology in the context of cultural heritage collections. A number of these projects are in partnership with archival memory institutions or large visual collections online. So I'll sort of run through a bunch of projects. I'm very happy to take questions at the end. So first of all, what do we mean by visual search? Visual search is all about querying visual collections using visual rather than text queries. So it could be a sketch, a photo, any form of visual media used as a query. And why might we want to do that? Well, you know, usually when we search collections, we search using text, and we leverage metadata that's associated with the records in that collection. But when we do that, we first of all presume there is some metadata, which is not always the case. And secondly, we're restricted to the kinds of tags and ontologies that metadata has been defined around. And by searching visually directly on the content, for example, the pixels of the image, we can maybe discover some new facets of the collection and sort of unlock ourselves from the definitions that the metadata that may exist with those records have been defined around. Let me give you an example of an early technology we worked on with the Visual Arts Data Service, the VADS. And this is some quite old technology. I want to start with this. We call it iTrace, and basically it was a kind of visual version of this Turnitin software that universities often use to do plagiarism detection in coursework submitted by students. And we wanted to basically produce a visual version of this, and we did so, and we trialed it at 4 different universities. You can see here an example of the interface where we have a piece of coursework here on the left and an identified record on the right from the Visual Arts Data Service. So this was a visual search. There's no metadata or tags involved here. So how does this sort of thing work? Well, back when we developed that technology, computer vision, which we now refer to as kind of classical computer vision methods, was all about identifying key points in images, features, and matching them between images. Here's another example of such a technique that we use to do landmark recognition, in this case around the University of Bath. This is Bath Abbey. The idea is to use detectors that detect important points in the image and then find some correlation between those points and a database of images in order to create a match. You can see this is an older piece of technology from the phone that's being used here. It's a mobile-based system. But you know, the world's moved on quite a bit since then, and now modern computer vision techniques, since about kind of 2012, now are largely based around, almost entirely based around deep learning. By deep learning, we mean neural networks that have been trained up to basically do some processing on images. So you can think of it as like a data processing pipeline. An image goes in here on the left, it passes through a bunch of layers which do learn to transform that image into some fingerprint or digital signature of that image on the right-hand side. And as the image goes through the network has learned to pick out different things about the image. It's learned to pick out bits of edge. It's learned that bits of edges combine to produce textures. The textures then are combined to produce object parts and ultimately whole objects. And this is how the network understands the images that are passing through it. One of the consequences of techniques relying on deep learning is that they also rely on the availability of a lot of data. So in order to train a network, we need access to large amounts of visual records in a collection. Let me show you an example of one project we worked on using the website Behance.net, which is a very large collection of artwork that is available online. Basically, creative professionals publish their work on Behance in portfolios, kind of show off their work and get work. So on the Behance website, there's a huge amount of content, over 150 million digital artworks, highly diverse in terms of their visual style and their semantics. And in this project, what we were doing was trying to learn from that data in order to build a visual search system. It's a little bit different. Instead of searching on what's in the image, we wanted to search on the style. So we wanted to find images that had a similar artistic style to a query. So how did we do that? Well, we put those images out for annotation. We had people annotate images according to the visual style of the artwork. So for example, comic book, graphite, pen and ink. We even looked at some kind of emotional aspects of the artwork. And we trained up one of these neural networks by showing it contrasting examples. So for example, we showed the network a watercolor bike, and we would show it a watercolor something else, like a watercolor flower. But at the same time, we'd show it a bike in a different style that wasn't watercolor. And the network would learn to tell the difference between similar styles and similar content in this way. And this enabled us to build a visual search system based on style. On this slide, we're kind of mapping some of the collection there on Behance, and you can see that similar areas of this map correspond to similar visual styles. And this is, so we're picking out example images here on the left, but on the right-hand side, you can see this kind of color-coded map of the collection where different styles correspond to different colors. And you can see that similar styles are close together in what we call the embedding, which is what this neural network has learned, the way in which it learns to match these images. One of the other things we tried exploring with this visual search system was combining it with another kind of creative visual search modality, just Sketch. And we did this project in collaboration with Adobe. So in this example, we built an integration into Photoshop where the user is, say, working up an initial design using a sketch, and they want to find some artwork that they want to incorporate into, in this case, a montage. And what they can do is condition that search not only on the sketch, but also on example artwork that exemplifies the style of the image they would like to find. And then the system go away and find that style, the thing they sketched in that style, and allow it to be incorporated into their montage. I've got a video of that process in action. Let me show you. We call this sketching with style. So the idea is you sketch, but you condition it on style. So unfortunately, in this case, it's me drawing, and there's a little cat here. The idea is we point the system not only at that sketch, but a folder full of example images, in this case, watercolor. And then when we do the search, you can see it's pulled back watercolor cats. And you can see many examples here of different things that have been sketched and different styles that we combine that sketch with in order to pull back a result. In this case, this is the top one result from the system. One of the other very interesting things you can do with a visual search system is, because you're not working with text, you can do things like do math with the different visual attributes of the system. So in this case, we have watercolor plus graphite. We've done a search with that. We've brought back images that have kind of watercolor, but also a lot of sketchy outlines. And we could do, say, watercolor minus graphite and get examples of watercolor washes that don't have a lot of that outlining to them. Or, for example, comic book traditionally has a lot of inking in it, pen and ink. But if we can ask the system for comic book without the pen and ink, you see that the system has learned something of the kind of repetitive nature of comic strips in terms of their layouts, and also the kind of vector art that accompanies those. And in this case, if we do search with vector art, we can ask the system for the opposite or negative vector art, and it comes back with these kind of like naturalistic sketches, which actually weren't part of the training set. So it shows the system can generalize beyond its data, which is very interesting. On the subject of sketch search, we also came up with this system called Live Sketch, which helps the user draw as they're searching. So one of the drawbacks of a drawbacks of a sketch-based search system is that not everyone can draw very well, or even want to invest the time into drawing very well to construct a search query. So in this system, the user's producing a sketch which is somewhat ambiguous. The results are being clustered according to the type of object being returned, and then by clicking on the sketch above each of these columns, each of these types of objects, the user's sketch is evolved towards a better sketch, a training sketch, that enables the user to kind of learn how to draw or refine their drawing as they're discovering content in the collection. I mentioned before that one of the necessary preconditions to using these neural networks is a large amount of training data. But in more recent research, we're trying to reduce the amount of data that's needed, at least the amount of annotation that we need on the data in order to train one of these neural networks for search. I've got a couple of examples of some work here from one of my colleagues in CVSSP, Miroslav Boba, and he has built a system here to do landmark search. So the idea here is that we want to identify or search based on the geographic landmark in an image. And this technique was entered into a Google and Kaggle competition back in 2018 and won that competition. It's a global competition in terms of the accuracy of the landmark search. We also did well in the Google YouTube 8 Million Challenge, where we won a gold medal for our video description technology, which takes in a video and then with very limited training data is able to describe what's going on in that video, which then would enable a text-based search on the video content. Another example of learning with very little annotated data is a refinement we made to the style-based visual search I showed a moment ago. We call this work Aladdin, and basically it's a visual search system that again was trained on Behance, but instead of putting out the images for annotation, so to train off sort of categories of style like watercolor or oil paint and so on, which is quite hard to define in a fine-grained manner, what we did here was train the system using the user collections on Behance. So on Behance, when artists publish their content, they publish them in these little mini or micro collections called projects. And just by looking at commonalities within those projects, our network was able to learn without any explicit supervision to say, you know, this is an example of watercolor or this is an example of oil paint. And you can see in this video here examples of search images and resulting content back from Behance from 150 million images searching on similar style. We've been exploring in the Deep Discoveries project some of the applicability of some of these visual search models I've introduced to searching a virtual collection that is a union of multiple collections or a national collection from multiple partner archives. I've got a screenshot here of a user interface that we're developing around the technology. This is work by Bernard Ogden at the National Archives and design work on the UX, on the user interface from the team at Northumbria. And basically this is showing the style search in action, but showing it's able to generalize to this national collection, virtual national collection. And this is ongoing work within the Deep Discoveries project. Another thing we're looking at in the space of style is seeing if we can bridge the gap between visual content and text. So in this project, we're actually clustering artwork and putting those clusters out to annotation by experts, in this case, art students at the universities of Edinburgh and Northumbria in their design school. And in this case, what we're doing is we've come up with like a novel way of annotating these clusters. It's based on grounded theory. And the idea is that we have the users, the experts, annotate clusters of artwork by describing their style. And then we train an AI up that is then able to learn from that annotation, a very small amount of annotation actually, and able to automatically tag artworks according to their style and automatically describe in natural language sentences the style of the artwork. And there are examples here on the right with very little training data. And in fact, we haven't explicitly labeled artwork with these tags. It's able to do what's called zero-shot generalization, which is kind of generalizing from its training data to stars it hasn't seen before, which is quite an exciting direction to take some of the star model work, because it opens up the search not only to visual search queries, but also you could then search on these generated tags and sentences using text-based search. Moving on to another aspect of cultural collections we've been looking at. This is some work from a project, HRC funded project called Digital Dance Archives. And at the University of Surrey, we have something called the National Resource Centre for Dance, which is a large collection of videos of old dance performance dating back almost 100 years. But also we have a lot of physical artifacts as well, like, for example, costumes that were worn during those performances. And we were able to get special permission to have a dancer specially trained in the choreography of, in this case, the 1920s, to wear one of these costumes for a short amount of time. And we captured the performance of this choreography using multiple cameras around a studio, and we're able to reconstruct a 3D model of this performance to kind of preserve that costume for the future. And once we do that, we're able to, as we saw here on the right, infer things like, for example, the position of the body inside that costume, and that opened up new ways to search that collection. So we had a bit of a fun exhibit that involved the National Resource Centre for Dance, where we had the captured, and the video's got some artifacts in it, unfortunately, here, I'm not sure why. We had the captured performance, and then we had this installation where a user, you can see here on the bottom left, makes a series of poses of human positions, and then the system then finds snippets of that choreography and stitches them together seamlessly so that they start and end in the different poses that the user is making in front of the camera. And that way the user gets to kind of be part of the choreography and drive the choreography through new sequences. So it's kind of in the spirit of the original choreography, but directed by the user. And another thing we're able to do with the videos in this National Resource Centre for Dance collection is to sketch, in a similar way, sketch a sequence of poses and have the system identify the choreography in the video collection and identify the video clips. And there's some examples of results here on this slide. So this is kind of combining the sketch-based retrieval with the choreography and the pose-based retrieval system. The last technology I want to touch on in this brief snapshot is a project called Archangel, which combined AI technologies with blockchain, which is another emerging technology. I don't have too much time today to define in any real detail what blockchain is. Many of you are probably aware of blockchain technologies from the media interest around cryptocurrencies and most recently NFTs. Blockchain, though, is really just a technology for multiple independent organizations to collaborate together and produce a shared, trusted data store. And that's important for things like cryptocurrency, where a lot of independent people like me or you want to operate and use cryptocurrency without recourse to, say, some centralized bank or something to track who owns which coins. But the same principle can be applied beyond financial applications. And in this project, we were working with the National Archives to underwrite the integrity of not just the UK National Archives, but other national archives around the world using this combination of blockchain and AI. Briefly, I'll outline how it worked. The idea was that when a video is ingested into the National Archives in, say, some born digital format, like, for example, the Supreme Court video records arrive in the archives in that format, what we'd like to do is fingerprint that video and store that fingerprint in the blockchain immutably, so that it's in a tamper-proof way, so that when that video is later released to the public can verify that that video hasn't been tampered with or accidentally corrupted while it was in the care of the archive. And we're using AI to develop that fingerprint and then store that fingerprint in a blockchain. And then the blockchain is maintained by multiple archives around the world. We had 5 archives in a 2-month trial we deployed of this technology, based not only in the UK, but also in Norway, Estonia, Australia, and also NARA, the US National Archives in North America. And all of those institutions are basically storing these fingerprints into the blockchain, a shared blockchain, to underwrite the integrity of their archives. And this was, quite a kind of pioneering work exploring how this AI technology could help protect the archives. So I see Laura turning a video on, so I shall conclude very briefly. The takeaway message I want to really give to you this morning is that text is very common search modality, but it is quite limiting for visual archives. And search and discovery in archives can be really exciting if we explore creative new ways to search them. We've looked at a few examples today: sketch, style, pose, choreographic search, even three-dimensional pose search and landmark search. Although AI techniques do require a lot of data, increasingly we don't need to rely on a lot of annotated data, which is the real bottleneck, using some of these emerging techniques in few shot and weakly supervised learning. And actually, even though these are visual technologies, we can link back to text-based search, as I showed, for example, with the style-based image description. Finally, AI technology is not just limited to search in the context of archives, but can also be combined with other emerging technologies like blockchain in order to do things like underwrite the authenticity and provenance of content. So yeah, I'm excited to take any questions you might have in the Q&A. Thank you.